The biggest players here are the effects plots. Effects plots are strictly about the practical effect, so don't get caught in the trap of making a statistical inference from them. In fact, as a consumer of a presentation, the only effects plots you should be shown are of factors that the statistical analysis said were likely impactful. There are two types of effects plots: main effects plots and the interaction plots. The main effects plots look like this. Now, it's just a line that shows the amplitude of the effect of the factor on the response. So the oven temp had that amount of an effect on the cookie darkness. It's very important to look at the scale on the vertical axis. If you don't compare it to the vertical axis, the line doesn't mean anything and can be misleading. Also, the main effects plot is not saying that it's a linear relationship. So why the straight line? Because it's a very easy way to visualize multiple factors. Check this out. You can see here that the oven temp has a larger effect than the bake time for those two ranges that we use for those two factors. Effects plots aren't graphing mathematical functions, they're just displaying the amplitude of the effect that was seen in the experiment. If you ever see an effects plot that looks like this, that has a symbol in the middle of the low and the high factors, that symbol is what's called a center point. It means that the team collected some data with all the factors set right in the middle of their ranges. Let's move on to interaction plots. Interacting factors affect each other's impact on the response. So for example, the length and width of a rectangle interact for the rectangle's area, right? If you change the length, it'll impact how much the width impacts the area. Interaction plots are very similar to main effects plots. They just break up the data across the two factors. If the statistical analysis found an interaction, then the interaction plot can indicate how strong the interaction is, right? Again, practical significance. So here's an interaction plot. What you're looking at here is how parallel the lines are, or really you're looking at how not parallel the lines are. The more out of parallel the lines are, the stronger the interaction. These two lines are very parallel, almost perfectly so, as if I just made up some graphs without any real data behind them. Here's a graph that shows a relatively weak interaction. The lines aren't parallel, but they aren't that far out of parallel either. And remember, when we're using effects plots, we're doing it to just understand the practical significance. We shouldn't look at these to judge whether the effect is real or not. The statistical analysis should have told us that, before we're even looking at these graphs. Now, this graph shows a strong interaction. So those are the effects plots, and they aren't very complex, but they can be misleading if you don't know what I just went over.